Okay, welcome back everyone. We're gonna go through an example using the chain rule to compute the derivative. I thought it would be good to start with something that we already know so that we can just see what it's like to have an online lecture and just get used to the terminology, or sorry, the technology. All right, so we have this function here. We have y equals e to the cosine of 3x plus cosine of e to the 3x. I just want to start by reminding us of the relevant rules here. So if you'll bear with me as I get used to this pen. So we're going to just start by recalling our two rules. So the main rule that we're going to use is just the standard chain rule. And so that tells us that the derivative of a composition of functions, so if I have f of g of x, that is going to equal the derivative of f evaluated at g of x times the derivative of g of x. What's also going to be relevant for us is a special case of this that we talked about in class. So remember, if we have the derivative of e to some function, so my exponential function, except instead of just x in the exponent, I have a function. So we talked about in class a shortcut for this, and this is really just using the chain rule, again, is going to be, or sorry, that derivative will always be e to the g of x and then times, maybe I'll put a dot in, times the derivative of g of x, so times the derivative of the exponent. Okay, so these are the relevant rules for us in this example. Okay, and so now let's go ahead and apply those. I'm going to try to scroll down a little bit. So looking at our function here, so the first term, we'll take the derivative of each term separately. So I'll start by computing the derivative of e to the cosine of 3x. And for that one, I'm going to use this second rule here because it matches that form. And so the derivative, so let me start this out. So my derivative, I'll have y prime is equal to the derivative of that first term. And so that's going to be e to the cosine of 3x. And then times, so I'll just write this out the long way to start, the derivative of cosine of 3x. And we'll work with that derivative in a second. All right, and then I'm going to add on the derivative of this second term. So what's my second term? My second term here is cosine of e to the 3x. If it was just cosine of x, we know that the derivative would be negative sine of x. And so now we're going to use the chain rule, so it will be negative sine of what's in the parentheses and then times the derivative of what's in the parentheses. Okay, and so that is, again, so it's going to be negative sine of what's in the parentheses, so e to the 3x times, I'm running out of room, but I think I'll fit it, the derivative of e to the 3x. Great. Okay, and so now I need to finish computing derivatives, and so on my next line, that is what I will do. So I have e to the cosine of 3x. I'm not changing anything with that. And then I want to multiply by the derivative of this term here. The derivative of cosine of x is, again, negative sine of x, but I have cosine of 3x here. So it's going to be, let me put parentheses in, negative sine of 3x, and then times 3. Okay, and again, this times 3 here, that is the derivative of 3x. I'm using the chain rule again. All right, so I'm done with derivatives on that term, and so it's going to be minus sine of e to the 3x, and the derivative of e to the 3x, so I can again use this second rule, or just remember our rule from before about how to take the derivative of the exponential function. This is going to be e to the 3x, and then times the derivative of the exponent, which is 3. All right, so I can leave my answer like this, or if you really want to simplify, let's see, how could we rearrange this so it will look nicer if I put the minus sign out in front and write minus 3 let's say sine of 3x. So I'm just changing the order around to make it look nicer. So negative 3 sine of 3x times e to the cosine of 3x. And then minus, let's say 3 e to the 3x times sine of e to the 3x. Okay, so either one is an okay final answer. There are other ways that you could write this, just rearranging the terms, but either one is fine. I would encourage you to just not do any rearranging at all, because then you will not make any algebra mistakes as you're rearranging or leave out any terms. Okay, so that is the end of this example, so I'm done. What I'm going to do now is I'm going to end the recording. You'll be able to see this document. I'll post it on Blackboard so you can look through the work again. You can watch the video over and over again if you would really like to. And please let me know what questions you have about it.